All right, so the angles and the sides of a triangle have a very special relationship. So when we start looking at the sides of an angle and the sides of the opposite side, there's this kind of proportionality here in terms of, if I have the size of all the angles, I can determine which side is the biggest, which side is the smallest, and which side is in between. All right, so a relationship exists between the length of a side and the measure of the angle opposite that side. All right. And so the idea here is the larger the angle, the longer the opposite side is going to be. All right. So the bigger the angle measurement, the bigger the opposite side is going to be. All right. And so that's the relationship we're looking at here. And so, for example, we want to list the sides from least to greatest. I want to figure out which of these sides, even though I don't know the measurement of the sides, I can still figure out which side is the smallest, which one is the biggest, and which one is somewhere in between. And see, it's all based on the sides of the opposite angle. And so when I think about least to greatest, well, let's find the smallest angle. If the smallest angle right here is this 20-degree angle down here, the side that's opposite that angle, in other words, the side that's not touching that angle, notice Y and Z are touching that angle, so as far as I can get away from that angle would be side X. Okay, so if 20 degrees is the smallest angle, it means that side X has to be the smallest side. So side X is the smallest of the sides. Next, I would go to the next size angle and say, hey, right here, the 40-degree angle. The 40-degree angle this time is across from Z. So X was the smallest. The next smallest angle is Z. But Z is going to be bigger than X because the angle across from Z is bigger than the angle across from X. All right? And then when I look at this thing, the largest angle, right here, the largest angle is the 120 degrees. And across from that is Y, which means Y is the biggest side in this thing because it's across from the biggest angle. And so I can write this as just an inequality. I would say, hey, X is the smallest, then Z, then Y. We could write as an inequality, although this one just says list from least to greatest. So I can just put some commas in between, say, hey, X is the smallest, then Z, then Y is the biggest. And that's it, all right? So there's a relationship between the size of the angle and the size of the opposite side, all right? One of the ways I try to remember this is I think about alligators, all right? Just like I do with inequality symbols. So if I think about this as an alligator, the 20-degree angle, see, that's the mouth of the alligator, is the 20 degrees. And you see what it's eating? Inside the mouth of the alligator is this thing right here, is this side. So that 20-degree angle is eating X. And so the smallest alligator eats the smallest meal, all right? When you look at the next alligator, like the 40-degree, that would be this alligator right here. So if you think of that angle as the mouth of an alligator, all right, the medium-sized alligator, well, look at what's inside the mouth of the alligator. It's this side. And notice it's slightly bigger, so it has a slightly larger meal, all right? So the bigger the alligator, the bigger the thing that it gets to eat. And then, of course, the biggest alligator, the 120 degrees, well, look at what's in the alligator's mouth. Its side Y is in the alligator's mouth. That mouth is open pretty wide here, all right? But the biggest alligator eats the biggest meal. So we kind of think of it that way. Think about the angle, and now look at the side that's across from it. The bigger the angle, the bigger the gator, the bigger the meal, all right? The bigger the opposite side. And so applying that same thing to the next one, once again, the smallest of these angles is this one right here, the 33-degree angle. And notice the side that we're looking at then, the side that the alligator is eating, the side across from that angle, is BC. So BC must be the smallest side because it's across from the smallest angle. If I look at the next one, 59 degrees is the next smallest side, or the next smallest angle. So the next smallest side must be AB because that's the side across from that angle. And then the biggest angle here is the 88 degrees. And that's across then from what must be the biggest side, which is AC. Okay, so once again, the relationship between the sides of the angle and the opposite side, the bigger the angle, the bigger the opposite side. Okay, so the smallest angle is across from the smallest side, the biggest angle is across from the biggest side.